Welcome at the last part. We're going to speak about grain cargoes. First of all, we just saw earlier, if we load non-grain bulk cargo, we need to comply and adhere to the IMSPC code. For grain cargo, there's another code made by the IMO. But some cargoes, which normally are not grain cargoes, but which are slippery and with a small angle of repose around 30 degrees, these conditions of the ships, the stability conditions, they need to be tested according to the grain code and not to the IMSPC code. Slippery, I mean non-adhesive, so not sticky, niet plakkerig in het Nederlands. Grain is a general term used for multiple kinds of organic products which are used for harvesting, for breeding cattle and to feed humans. Examples are wheat, maize, oats, rye, barley, rice, some seeds, and if we need to adhere to the grain code, it's loaded as a bulk cargo, so without any outer packaging. Here we see spout trimming, the last amount of tons finishing up this hold. So the grain code, inside the code there's information about stowage, the stability of the ship, and strapping and lashing of parts of the grain cargo. The code is into force since the 1st of January 1994. When a new ship is built and if it's fit for transporting grain, prior to the first trip, class will make a calculation for a certain grain condition, and the captain can always ship grain in that way, in that manner, if he sticks to that plan which is pre-made by class. If he this condition gets a document of compliance, and if the master is loading the ship in another way than mentioned in this grain loading manual, the master needs to prove to flag state or port state that the ship in that condition is seaworthy, and often it needs to be done by a handmade calculation. Besides the calculation, prior to the loading, the cleanness of the cargo hold is crucial. I hope you can imagine that if humans eat grain, the standards for cleaning are higher compared to shovel clean or normal clean. So grain clean requires that the holds to be free from insects, odor, residue of previous cargo, lashing material, loose rust scale, and paint flakes. And prior to loading, the holds must be swept, washed down, rinsed with fresh water, dried and well ventilated. They accept light rust of steel, but not any loose scale or paint or loose parts of rust. So it doesn't need to end up in your porridge someday, so they don't accept any loose scale or paint or rust, as I just said. So prior to loading, some inspector, we call that guy a hold surveyor, will survey the hold, and he will check if the hold is made clean enough, sufficiently clean according to the grain standards and as written down in the charter. That's his job. It's good to bear in mind that this guy, the hold surveyor or woman, he works for the shipper or the receiver of the cargo. He doesn't work for the ship. So it's something to bear in mind. If you receive a hold cleaner surveyor on board. Nowadays, if the hold is quite big, they make use of drones now and then to get to parts which are high and not easy accessible. And these drones are equipped with video cameras, and these images and movies are stored as a kind of a proof in case some dispute arises. So prior to loading, no flakes of paint or rust, no traces of previous cargoes, no traces of infestation, so small bugs or animals, also rats. You need to have a valid de-ratting certificate. The cargo hold bilge wells, they are cleaned and tested, and they are covered with burlap. In Dutch we speak about jute. En dat zijn bijvoorbeeld die Sinterklaaszakken, die zijn van dat materiaal. The hold needs to be ventilated and rinsed down with fresh water. Sometimes you need to wash twice, and to spare a little bit of fresh water the first round, they use seawater. So here an example of covering up the bilge wells in the cargo hold. Here you see the Sinterklaas zak materiaal, the burlap, and they put some little container tape around it as well. It needs to stay in place, because I hope you can imagine if the grain particles fall down in the bilge well, you might be ending up suck grain inside your bilge well system, inside the piping system of the bilge wells. That's not a good thing to do. Besides the bilge wells, there are other gaps to be closed, to be sealed. Here you see an example. This is actually salt, but for grain it would be the same. This door or this ship is equipped with side doors. It's a ship from Splitov, but you see here they cover the gaps here of the door with container tape and some plastic dunnage. Another item to be aware of is sources of ignition inside the cargo hold. It needs to be locked down and tacked off prior to loading, because it can be a source of ignition and heating, and you can cause a fire if you have a lamp burning in your cargo hold. So be aware of sources of ignition. So bilge wells need to be covered by burlap, otherwise you might suck grain into your bilge system. Dust explosion is a risk due to that grain or particles are so small. Oxygen molecules can surround these particles fairly easy, and it means in case there is a source of ignition, the speed of the combustion will be high, so the explosion will be great and intense. Another danger is the angle of repose of grain. If you pour out of one location the grain inside the cargo hold, the mathematical form which forms is the shape of a cone, in Dutch a kegel. Due to that, the organic skins of grain, they are a bit slippery. There's not so much friction on the outside of the skin of the grain particles. The cone collapses at a very small angle. So this angle with the horizon, I indicated here, this angle is called the angle of repose, and in Dutch we call this storthoek. The collapsing of a cone of grain or any other movement at all needs to be minimized. If we are seaworthy, the transfer center of gravity, dus de dwarsscheepse ligging van punt G, the transfer center of gravity needs to be in the center line. Then we are having a zero list, and that's how we go to sea. In case the grain moves in the cargo hold, it means that the transfer center of gravity will rapidly come outside of the center line, and that gives a list to the vessel, and this list can be dangerous. Here an example what happens. We have a ship with grain, and as you can see the ullage is higher than 0. This is the ullage, and there is room for movement for the grain. So if the vessel starts rolling and the vessel gets at a list higher than the angle of repose, in that case the grain starts moving, and you see it on the right side. We use a system out of mathematics where we look at the triangular, and we do it in another lesson. But what's indicating here, and we can calculate the amount of movement of the transverse center of gravity to transverse center of gravity with an accent. And we use these two triangulars which are formed if the angle of repose is achieved. So this is basically what happens. Point G, the transverse center of gravity, is moving towards the side of where is the grain higher, and we use these two triangular parts out of mathematics to quantify the amount of movement, and also the amount of movement is it's linear with the amount of list what is forming afterwards. Well, the core of the grain code is that in the condition of G accent, the ship needs to have enough remaining stability to continue the voyage. That's basically the core of the grain code. We can prevent minimizing the movement of grain inside of the cargo hold. If the draft mark allows, we can load till 0 ullage. So we fill up the cargo hold till the top of the hatch coming, and then close, and then we have basically 0 ullage. It's not always possible because you cannot continue or start your sea voyage with less than the minimum freeboard according to the rules. That's not allowed. Another option we do is we trim the grain cargo horizontally flush. Sometimes it's done usually by hand with cleaned brooms and stuff. Another option is make a saucer, in Dutch een kuil, and we put some burlap burlap coverage in this saucer, and then we fill up additional cargo of grain inside grain bags, and we close the bags and we pile them up, and we strap the saucer and the bags according to the grain code. That's allowed to minimize the movement of the grain. Another option is using vertical and horizontal bulkheads to minimize the ullage. Well, we're not gonna speak about it this clip, but there's a relation between ullage and the grain moment. We're gonna speak about it later. Another option, which is a bit more costly, but might be favorable in case you need door-to-door transport. It's the use of bulk containers. Nevertheless, the containers, they have their own weight, and we can discuss whether this is an economical, favorable way to ship a big party of grain. Small parties should be okay like this, but big parties, it's not that clever because we are also moving a lot of steel of the containers. So there's some loss of dead weight in that case. That's it for now. Thank you very much.